Hey, good morning. Tim Warner here. You know, a question that I ponder fairly regularly is that of nature versus nurture as it relates to skill development. And I always think of music, probably because I'm a musician. But I think if you were to just grab some random people, regardless of age, socioeconomic status, culture, race, gender, whatever, random sampling of people, and asked them to participate, say, in a series of piano lessons or voice lessons or something like that, what would emerge? I believe that we'd see a variance of natural or native aptitude for, say, playing the piano. But I'm more interested in somebody who knows that they don't have that facility. Can they, through sheer force of will, determination, and open-mindedness, develop a level of competence anyway? It seems pretty clear anecdotally the answer to that is yes. However, how much they would excel is the question. This comes back to a thesis that I've mentioned in my other videos and probably will continue to mention. I believe in it so strongly that skill development is the marriage of recognizing your natural aptitude so you can build and really supersize that skill set. Genuine interest, because without that genuine interest, you're going to miss that third piece, or at least you won't be sufficiently motivated to put in the time and effort required to build the skill. Specifically, more so, I think about what does it mean to think like a programmer? And oftentimes people that I talk to in the industry and out immediately have a recoil reaction when they think of programming because they just think of math and they think of formulas and algorithms, and it scares them. Because math anxiety, let's face it, is a real thing. Quick acid test to determine if you've got some native aptitude and interest in thinking and like a programmer, becoming maybe a software developer. Let's consider, for example, that you're tasked with creating a computer program that, very simple, we're not talking about VR or 3D graphics, a character-based, text-based, simple, dead simple program that's a number guessing game. How are you going to think about solving that problem? Forget about programming languages and frameworks and all that either. I'm thinking really napkin sketch kind of stuff, or what's called pseudocoding. Well, I'm thinking of, first of all, what are the requirements of the game? What's the perimeter of this program going to be? Is the random number going to be between 1 and 10, 1 and 20? Let's say 1 and 20. Is the player going to be capped at a certain number of guesses? It would be reasonable to say yes, so let's say 5. And if the player gets the answer correct, maybe we could keep a score. So these sort of things are important to keep in mind right at the outset so we know what we're building against in terms of our perimeter, our solution requirements. Then when it comes to actually creating the program, we want to think about it imperatively. We want to think about where's the entry point of the program the user starts at. We're going to have the program welcome the user with or without a personalized message, maybe briefly outline the rules of the game. But ultimately, we're going to need to hand the control back to the user. We're going to need some sort of loop structure, a conditional loop structure, such that while we're in that loop, while the user is going back and forth with the program guessing, we want to keep in mind, are they too high to the target number? Are they too low? Did they actually guess the number? And just as importantly, what happens if a user hits an illegal key? I mean, if the number's between 1 and 20 and the user submits F, what do you want? I mean, if you don't handle that exception, then the software is going to crash, and that's going to be a negative experience for the user, and we don't want that. So that's really what I'm getting at in terms of thinking like a programmer, thinking about problems and solutions algorithmically, thinking about breaking them down into modules or chunks. We've got the entry point and setting up the environment of the application. We've got that main loop where we've got a condition that as long as the user has not correctly guessed the answer and it's less than say 6 attempts. If we're going to cap the number of attempts at 6, we're going to, receive a value from the user, and then we're going to perform some conditional logic there, aren't we? If the user's guess is too high, if it's greater than the pseudo-random number that we had the program generate, then we give them the message too high and then return to the beginning of the loop. If the guess is too low, if it's below the target number, similar thing, we'll tell the user and return them to the loop. And then for exception handling, if the user puts in anything but a digit, and in particular, we might want to constrain that even more, that if the user puts in either a digit below or above 1 to 20, or hits a non-numeric character, then we're handling that exception. Whoops, you need to make sure, and we're going to tell the user what the legal values are. And then, of course, we've got the conclude condition of the application. Either the user's run out of guesses, game over, or they've correctly guessed the number, et cetera, et cetera. You see how that works? So algorithmically thinking about problems. And it's natural for me as a neurodivergent person, and anecdotally, I'm not a sociologist, of course, but anecdotally, knowing a lot of people in the industry over the last 25 years, I see what I believe is a significant number of neurodivergent folks like me who gravitate towards information technology in general and software development in particular. Why? Well, if you're autistic like I am, then it comes very naturally to think about problems in terms of perimeter, scope, and then breaking down atomically the situation into manageable chunks and linking them together. So thinking procedurally, thinking of algorithms. And an algorithm is simply a routine that's deterministic and repetitive that's going to solve a particular problem or give you an expected result. So if you resonate with what I've been talking about these last several minutes, I would encourage you to maybe go a little bit further. Check out Pluralsight, check out Code Academy. There's plenty of sites where you can learn to code and learn to program online and even for free. And see what you've got there, because if you've got that, at least a kernel of natural aptitude, you combine that with the time and the interest, I'm telling you, I'm a happy camper having been in the industry. I'll tell you that. I can't imagine doing any other kind of work, to be honest with you. So let's see, as usual, let me see if I've forgotten anything, because this is an unscripted live without a net situation as usual. I've noticed on the IT operations side of the fence over the last 10 years or so, we've seen a trend in industry towards what's called DevOps, where you've got your software developers and your systems people, infrastructure, network people. Instead of working separate in parallel silos and not communicating very often, the principle of DevOps is just the opposite. Why not put our heads together and unite? Why not cross-train a little bit and our systems people learn some software development practices, our software development people learn some infrastructure as code, for example. We can meet in this shared methodology to do work faster and to deploy and support our users and our services more efficiently and safely than we ever have before. And I say that because I've noticed on the system side, still to this day, I'm sure it's a very long tail, some resistance because some of those people chose the IT operations side of the fence strictly because of anxiety about the programmery stuff and just assuming, oh, I don't have that in my wheelhouse, in my skill set. But I submit that if you're really looking to future-proof your career and you're not a developer, you're doing yourself an enormous solid by working to think like a programmer. And there's actually a book on the subject by No Starch Press. If you go to Amazon and look for Think Like a Programmer, it's a good book. There's a bunch of logic puzzles in there. It's meant to, I think, get your brain thinking more algorithmically. So I would recommend that book. Again, it's called How to Think Like a Programmer, and it's by one of my favorite publishers, No Starch Press. They have a lot of personality in their titles and in their style in general. All right, Areno, I think we'll call it at that. Thank you as always for hanging with me. I'll see you in the next episode.